Hello friends, welcome back to my YouTube channel. So in last video we have seen some basics of the unit load method. So today we will see a problem on this. So the given problem is find horizontal displacement at point D. Take E is equal to, E is nothing but our Young's modulus 210 into 10 to the power of 4 Newton per mm square, and I is nothing but moment of inertia 3 into 10 to the power of 7 mm square. So by using unit load method, or it is also called as the virtual work method. So this is the given problem. See here a E value given is 210 into 10 to the power of 4 Newton per mm square. They gave in mm square, and I value also they given mm to the power 4. So we need to convert this into kilonewton into meter. So I will show you how to convert this mm into kilonewton into meter. So later I will tell you. So now we will solve the problem. So this is the given problem. At point A, in support is there, here on roller is there, and that BC is carrying the UDL of 30 kilonewton. So in usually what we have to do is, the first thing what we have to do is we need to find out the support reaction. So at in support the number of reactions will be, one is vertical, so call it as VA, one is horizontal one, that is called as HA. At point D, roller support is there. At roller support only one reaction will come, that is vertical, call it as VD. So now first we need to find the reaction of support reactions. So for that we will take the summation of all the vertical forces is equal to 0. Upward we need to take the positive. So before solving this, we need to find the summation of all the moment about point A is equal to 0. Clockwise we need to take the positive. So here VD is moving anti-clockwise. So anti-clockwise is minus VD into at a distance of 3 meters. So we need to always see the perpendicular distance. For VD, this BC member is perpendicular. Now we need to take the always perpendicular distance. So VD into 3. So minus VD into 3 we need to take. Minus VD into 3 plus, here the UDL is acting, so it also rotates clockwise. So 30 into at a distance of 3. So UDL always act at the distance of L by 2. L by 2 is nothing but 3 divided by 2. So it is clockwise. So plus 30 into distance is 3 meter is always act at the distance of L by 2 is nothing but 3 divided by 2. And here 10 kilonewton point load is there. It also rotates the clockwise. So 10 into at a distance of 2 meter. So plus 10 into 2 is equal to 0. So now solve it. Our VD will come out as 51.66 kilonewton. So it is positive, means upward. So whatever the direction we have taken is right. So it has the value of 51.66. Similarly we need to find the VA and HA. So now for VA, summation of all the vertical force is equal to 0. Upward we need to take the positive. Here VD is upward. So 51.66 plus VA is also moving upward, VA, and if you convert UDL to point load, it comes downward. So minus 30 into at a distance of 3 meter. So minus 30 into 3. So solve it. Our VA value will come out as 38.34 kilonewton. It is also upward. So whatever the direction we have taken was correct. So 38.34. Similarly for HA, summation of all the horizontal forces is equal to 0. We need to take left to right one positive. So here HA is moving right to left. Now we need to take the negative. So minus HA plus, here 10 kilonewton is moving left to right. Now we need to take the positive. So 10. Is there any horizontal load? No, only 2 is equal to 0. So solve it. Our HA will come out as 10. So 10 means, so this is how we need to find the all the support reaction. So we have find all the support reaction. So next what we have to do is, so what they said to find the horizontal displacement at joint B. So it means at joint B we need to find the horizontal displacement. So for that we need to remove the first all the external loads. So whatever they are given, it may be 10 kilonewton or 30 kilonewton, we have to remove it. We need to apply at point D, so unit load of 1 kilonewton. So they said to find the horizontal displacement at point D, no, that's why we need to apply the, according to problem, 1 kilonewton we need to apply here. So to balance this load we need to apply the here also in this direction 1 kilonewton, because our frame always should be in equilibrium to balance. So that's why to balance this I have applied the 1 kilonewton of load here in this direction. So now this diagram is call it as the small m, and this call it as the our capital M. So now what we have to do is we have to, so here 10 kilonewton is there, give it to the name point E. So here also point E. So now what we have to do is, now we need to make a one table. Here it has the member, origin, limit, capital M, small m and EI. So member is nothing but whatever the member we have, AE, EB and BC and CD. So same thing I have written here. For AE I have taken the origin as A. So here origin, in this remember one thing, we have to cut the section away from the point, and that we have taken as the origin. Here we have taken origin as A, no, we need to cut the section here like this away from the origin. So I will tell you while solving. So similarly for AE I have taken the origin as A, for EB E, for BC C, for CD D. And for limit we need to see the, for member AE we have the distance of 2 meter from A to E is 2 meter. 2 meter is nothing but our 0 to limit is 0 to 2. Similarly for EB also distance is 2 meter, so limit is 0 to 2. For BC we have the distance of 3 meter. 3 meter is nothing but limit is 0 to 3. And for CD we have the distance of 4 meters, 0 to 4. So for capital M, for member AE we have taken the origin as A. It means we need to cut the section, x-axis section away from the origin A. So now see here, the sign convention I will tell you here. Upward we need to take the positive, and downward we need to take the, which is moving downward we need to take the negative, which is moving upward we need to take the positive. The value we got was, it is make it as positive 10, so it comes positive 10, because minus h into minus h plus 10 is equal to 0, so h will be obviously plus 10, so positive 10. So for AE we have, so here HA value we have 10, write it here 10. So if we see, I will show you. So this HA is moving like this, no, like this means it is moving upward. So at a distance of from here to here is, from this section is x. So at a distance of x it is moving from here to here. It is moving upward means we need to take the positive, that is 10 into x. So our m value for AE is 10 into x. So write it here 10x. Similarly for m, small m, if you take the section AE, so we have taken our origin as A, no, we need to cut the section far away from the origin A at a distance of x from here to here. So similarly it also moves upward, so at a distance of x from, so upward means we need to take the positive, so 1 into x is nothing but x. So m value is x. So here I will write it later. So for EB we have taken the origin as E. So for EB we have taken the origin as E. We need to cut the section away from the origin E at a distance of x. So now the 10 kilonewton it is coming upward, no? So at what distance from this section it is acting? So 10 into from A to is distance is 2 meter, no? From A to E is 2 and from here to here is x. So it means 10 into 2 plus x. So it will be 10 into 2 plus x. Our capital M. Here h is moving upward. So 10 into at what distance it is moving from this section is 10 into from here to here is 2, no? 2 plus here to here is x. So 10 into 2 plus x distance it is moving. So our M will be 10 into 2 plus x. Similarly for M, if you cut the section x axis away from the origin E at a distance of x, so or 1 kilonewton from this section, what distance it is acting is 1 kilonewton into from here to here distance is 2 meter, no? Here to here is 2 meter. See here 2 meter. 1 into 2 plus x. This is x. From here to here is x and from here to here is 2. So 2 plus x distance it is acting. So our M will be 1 into 2 plus x is nothing but 2 plus x. And similarly for BC we have taken the origin as C. So for BC we have taken the origin as C. It means we need to cut the section here x axis at a distance of x from the origin. So why we have taken the origin as C means here. So if you have taken origin as C means we need to calculate from here to here. Here we only have the one load, now it is easy to calculate. So if you consider for BC section as origin as B, then we need to cut the section here. So then what we have to do is here we have this load VA and 10 kilonewton from we need to calculate from this segment. It will the calculation becomes a little lengthy. That's why for easy calculation I have taken the origin as C. For BC I have taken the origin as C for easy calculation, because here we have only one load, so it will be easy to calculate. So VD is moving upward. So upward means at what distance it is moving, we always need to see the perpendicular distance. Perpendicular distance means, so VD is 51.66 into this distance is nothing but our x. So 51.66 into x. Here one UDL is there. UDL of 30 into at a distance of x divided by 30 into weight. I will write it here. So for VD it is moving upward, no? We need to take 51.66. We need to always take the perpendicular distance. Mean for VD this is the perpendicular. So 51.66 into x minus here one UDL is there, no? So if you convert this into point load, it moves downward. So minus 30 into at a UDL at what distance it is acting? It is acting at a distance of x, no? 30 into x. So UDL always act at the distance of L by 2. L by 2 is nothing but x. Our distance is x, no? So x divided by 2. L is here x. So x divided by 2. So now solve it. 2 1 ja, 2 15 ja. So it will become 51.66x minus 15x square. So write it here. So our M will be 51.66x minus 15x square. 15x square. Similarly for small m. So for small m, if you cut the section x axis at a distance x from the origin C, so the 1 kilonewton is moving upward, no? So for 1 kilonewton, at what distance it is moving? 1 kilonewton it is moving horizontally, no? We need to take the perpendicular distance. The perpendicular distance of this CD is 4 meters. So 1 into 4. So we always see the perpendicular means it is moving horizontal. For this horizontal load, if it comes here, so our CD becomes the perpendicular. So 1 kilonewton is moving at the distance of 4 meter from this section. So our small m will be 4. Small l will be 4. Similarly for CD we have taken the origin as D. We have taken, if you cut the section x is far away from the origin D at a distance of x. So at what distance the VD is moving? So it is moving, so this is axial to this member, no, it becomes 0 because 51.66 is moving on this member, no. The perpendicular distance of this becomes at 0 distance it is moving. The M for this CD becomes 0 because the VD act at the distance of 0. Similarly for small m, if you cut the section away from the origin D at a distance of x, so the 1 kilonewton is horizontal, it is moving. So perpendicular of distance of this 1 kilonewton will be this one. This one is nothing but our x. So 1 into x. So small m becomes x. So this is how we need to fill the table by using these two diagrams. So I hope you all are understood this concept. So now what we have to do is we need to apply the integration formula. So I will show you. We need to apply this formula. YD is equal to integration of 0 to L capital M small m divided by EI into ds. We need to apply this. Same thing I will write here. YD is equal to integration of 1 divided by EI I will take outside. It is later I will solve for that. So for AE, this into this, I will write here formula. YD is equal to integration of 0 to L capital M small m divided by EI into ds. This is our formula. I have taken EI outside. So now integration of 0 to L. For AE limit is 0 to 2. So 0 to 2 capital M into small m. So this into this, this into this, this into this we need to do. So for CD member the value is 0. 0 into anything becomes 0. So I will take only these three. So for AE 0 to 2 limit. So capital M is 10x into x dx plus for EB limit is 0 to 2 integration of 0 to 2 this into this. So 10 2 plus x into 2 plus x dx plus integration of for BC limit is 0 to 3. So 0 to 3 into this 51.66 x minus 15 x square into dx. So now close it. For CD 0 into anything becomes 0. I am not taking it now. By using calci we need to solve for YD. I will show you how to calculate it. See here, you need to write here 4 also. This into this 4 is there now. So I will write 4 here. This into 4. So now solve it. Integration of 0 to 2 into 10x into x plus integration of 0 to 2 into 10 plus 2 plus x, 10 into 2 plus x into 2 plus x. So 10 bracket 2 plus x, close the bracket, again 2 plus x. So close the bracket. So plus this one plus integration of 0 to 3 into 51.66 x minus 15 x square, close the bracket, into 4. So now solve it. Our YD value will come out as 603.21. YD is 603.21. Write it here. So divided by EI is there. Write it here. Now we need to find the EI value. So our EI value, E value they gave was how much? E value is 210 into 10 to the power of 4 Newton mm square. So convert this into kilonewton meter. So we need to multiply. Wait, I will write it here. 210 into 10 to the power of 4 Newton per mm square. So 21 into 10 to the power of 4. To convert this into kilonewton meter, we need to multiply this into multiply this into 10 to the power of 3. So it will come out as 210 into 10 to the power of 7 kilonewton per meter square. We need to make it into meter square. Similarly for I, we got the value for I 3 into 10 to the power of 7 mm square. So 3 into 10 to the power of 7 mm, need to make it meter square. To make it into meter square, 3 into 10 to the power of 7 into multiply this into 10 to the power of minus 7 meter to the power of 4. So it will come out as 3 into 10 to the power of minus 5 meter to the power of 4. Now substitute this in this value. So 603.21 divided by E value is 210 into 10 to the power of 7. 210 into 10 to the power of 7 into the I value is 3 into 10 to the power of minus 5. 3 into 10 to the power of minus 5. So if we do, the value will YD value will come out as 9.57 into 10 to the power of minus 3 meter. So it will come out as this. So this is how we need to find the YD. So this is the procedure of finding the unit load method. In case of unit load method, so while find out in the deflection, we need to put all the value in meter only. So this is the important one. You need to remember this thing. We need to make it whatever it is, maybe mm square or mm4, we need to make it into the meter square. We need to put all the value in meter only in case while find out in the deflection. So this is how we need to find the, and see here we have made one mistake here. So for summation of fx, so initially we have taken, we need to assume, so before finding this HA, we need to take the HA in direction, we need to take, so HA is equal to, it becomes for calculating, so positive, so plus HA, because we need to take the left to right positive, no, so left to right positive means we need to take HA is for positive, plus this is 10 kilonewton also moving left to right. For that we need to take the 10 is equal to 0. So our HA will come out as minus 10. So it come out as minus 10 means the direction will be like this, like this. So that's why I have written here the direction is like this. So we need to, whatever the direction initially we have taken, assumed, that is left to right was incorrect. So our direction of HA will be right to left side. So for that we need to correct it direction, and the direction itself says it is negative, so we don't need to put here negative also. And the HA value is here minus 10. So the all the value becomes for M and M1 will be same, similar after changing this minus 10 value. So you may, so see here for M1, so our HA is moving, we need to see that it is moving clockwise. No, clockwise means we need to take the positive like this. So 10 into x, so everything will remain same after this value. So here also if you want to find the, you should find the reaction of this member. The reaction after we need to find the, here our hinge support is there. For hinge we have the two reactions, one is HA and one is VA, and one is our HA, horizontal and vertical force will take place. And for similarly for roller, only vertical will take place, VD. See here at this frame there is no any vertical load, so our VA becomes 0 and our VD also becomes 0. Similarly for HA, summation of all the horizontal forces is equal to 0. So before the finding this I am telling, so we have only one applied 1 kilonewton of unit load, so we need to take positive this direction. So 1 kilonewton is moving positive, no? 1 plus Here our HA is moving also positive. So HA is equal to 0. So our HA becomes -1. So -1 means the direction will be like this. So that's why I have taken here HA is -1 kilonewton. So after finding the reaction also, the solution remains same. So whatever the table we have calculated, this is also remains same, and this calculation also remains same. Everything will be same, nothing will change. So after finding out the reaction of this support and changing the HA into -10 also, everything will be same. Don't get confused here. Deflection. So here our problem ends. So if you like the video, like it, share and subscribe for more videos. Thank you for watching.